Okay, so today we're going to begin our in-depth study of arrays. We've definitely touched on arrays before. We have used them before, but this is kind of our last major focus on arrays. So we're going to push through quite a few different example problems. We're going to build towards problems that would be like on the free response portion of the AP computer science exam over arrays. After we do arrays, we'll go back and we'll use array lists. Array lists are kind of like arrays, but they're easier to use. They're more luxurious. But we need to know how to use arrays. They're more lower level, more into the computer, and they're kind of the foundation of things like array lists. So first I want to talk about what an array is. So an array is a contiguous memory block. So what I mean by that is that you can think of the array of memory in your computer as one long stick, and that's called RAM. And we can section off these bits of memory into 32-bit chunks. That means 32 ones and zeros, okay? We can also use 64-bit chunks if we're storing something like a long or a double. But an int is 32 bits, as well as a reference to an object. So for the first thing I want to go over is what happens when we make an array of something that is 32 bits, that being an int. So first of all, we need to talk about how do I declare and make an array. So if I'm just going to make an array, and I'm not declaring it as an instance variable, maybe it's just a local variable, then first I need to tell Java the type. And the way you say that the type is an array is you say what your array will hold, and then we put square brackets after it, and that indicates that this is an array of int values. So this is the type. Remember that Java is a strongly typed language, so we have to tell it the type. Anytime you make a variable name that has not yet been written before, the first time you say the type. I'm never going to say int array after this line of code, though. All right, I'm going to just call this array R, very common name for an array, ARR. And it gets... Now, here's where things get confusing. Java allows many different ways to make an array in order to support people coming from different programming languages. In fact, you can even put these square brackets after the R instead of the int and be an array. But we want to do things in a Java way. Yes, they support ways that are more like for C++ programmers and other kind of programmers, but we want to be Java-like. So an array in Java is an object. There actually is an array class that you're instantiating. It happens to be a private class, which is something that's really unusual. So we don't have access, we don't get to change it or anything like that. But they allow us to call it like this. So we say new, because anytime you're creating a new object type, we say new, right? Then we call the constructor. Well, see, the constructor is kind of weird. It's not like a normal constructor. You say new int, square bracket, and then what we want to do is we have to tell Java the size of the array. We have to. So I'm going to say 4 for this example. And then semicolon. We now have an array of size 4. It turns out that you don't actually need the new word all the time. Okay? But sometimes you do. We're just going to use it all the time. All right, let's go over what happens when you say that. It's very important you understand how this works in the memory. So Java will go somewhere in your memory, okay? And it will pick a location that R will point to. R is what we call a reference. So the array is not in R. The instructions on how to find the array is in R. A location, if you will. Like OX7A134, etc. Okay? Some gobbledygook hexadecimal number that the computer understands as a location. Now, when we said size 4, Java knows that it needs to start here and section off 1, 2, 3, 4 places in the memory. Now, if I make another variable like x, and it will make it somewhere else. So let's say I said I want to make another variable called int x equals 9. Well, because I sectioned off this array, this block of memory is not available. So it has to go somewhere else. It has to put the 9 somewhere else, and so it might put the 9 like right here. Okay, but we've reserved this. So the question is, how does Java reserve it? Well, it reserves it by actually initializing it to numbers. And the default value is what will be initialized, and they will be all zeros. If they're doubles, it'll be 0.0. If they're Boolean arrays, they'll be all false. And if they're if it's an array of object types, it will be all null for each one. But it has to store something in there. And that's part of how it reserves it. We can then set values of our array. We can do something like this. We can say R bracket 0. Now, R bracket 0 is the first element in the array, and we can assign it a number like 7. And what that tells Java to do is to go where R is. Remember, R points to the first thing. And it does something kind of neat. It actually takes this number here and multiplies it by 32 bits, and that tells it how far to move over from this point. Because more precisely, this references right here to that leading bit on the ones and zeros of your memory. And since I said R bracket 0, that means it goes right there and doesn't move. So it would take it and would write that number down as a 7. Okay? And because ints are primitive, it will literally write the 7 right there. Okay? Now, what happens if I do something like R bracket 2? Gets a 9. Well, what happens is Java will go, again, R tells it where to go, that first bit, and it's going to multiply 32 bits, the size of 32 bits times 2, and that tells it to go, there's 32 bits times 1, there's 32 bits times 2. So it puts it right here, and it knows now where to go, and that makes that a 9. And so that's kind of why we start counting at 0, so the math works out that way, so that the computer is able to randomly access any one of these different locations using simple multiplication for the size of the bits in each spot. Okay, so that's how we store different values, and we can write over them as often as we want, but what we can't do is enlarge this array. This array is set in size. It was set in size here. I can't just all of a sudden enlarge it. I could make a new array and copy that's bigger and copy stuff over to it, but I can't change this array size. Let's talk about how to access an element in the array. The way you access an element array is, say I wanted to print it, right? is you say the name of the array and then bracket the index you're looking for. So if I say 2, this would actually print out a 9. It's important to know how to find the last element in an array because we oftentimes don't know how big an array is, and that is at the length of the array minus 1. The length of the array is the size. And notice how length does not have parentheses. It's actually a variable. It's a public variable you have access to. So the length of the array minus 1, that would be this index right here. So what we're going to do now is we're going to practice in BlueJ making some arrays. We'll make some that are temporary. We'll make some that are instance variables. And we want to practice accessing and looping through what I call processing arrays. So if you would open up BlueJ for me, please, and make a new project called Array Demos. All right, let's just make a new class, and we're going to call this Array Practice. And I'll just Control A, delete. All right, now if I wanted to make an array that was available in every method that I write, then I need to declare it out here like this. And I don't have to put a size on it because I'm not actually making the array here. I'm merely declaring that the variable name array needs to be available everywhere. But I just want to deal with an array that is what I call temporary in scope, that only exists inside this method here. So once you make a variable inside a method, it's only available there. In fact, it's deleted from the memory when you're done running the method. If you run the method again, it makes it again in the memory. So let's make an array. Since it's deleted at the end of the method, we don't need to worry about making it private or public. In fact, I don't think it even allows me to say private. So we'll call this array. And I want you to make a new array of size let's say 7. And now we're going to add the numbers to our array. We're going to add the numbers of just some random integers. You could use your phone number if you want. I'll just use, I think I'll say 8. Then I'll make index 1, 6, 7, 5, 3, 0, 9. All right, so I've now made an array of that size. And we can access different elements in the array and print them out. So I'm going to print out array bracket 4. And so when I run this, you'll see that at array bracket 4 there was a 3. and I could print out any one of them. I could also get values from my array and store them into other variables for access to them more easily. But remember, I have to type it because I'm making a new variable name. So maybe I'd say int num gets array bracket 6. And now I've got a copy of that value right here. It's a primitive, so it's actually a copy, not another reference. We'll talk about references in the next lesson. And so that's how I would get a value from an array and store it somewhere else. Now, what if I wanted to loop through the array and print all of them? Well, I would say for int I equals 0, I less than array dot length. And remember, the length of my array is 7, but as you can see, the last index is a 6. That's why I have to say I less than, not less than or equal to. Then I plus plus. And now I can loop through the array. Like so. And print out each element in the array, one at a time. I could also add each element in the array one at a time. Okay. I could also print the array backwards. If I wanted to loop through the array backwards, so if I want to loop through backwards, I would set I to the array dot length minus 1, and then we would say, it's because there is an index 0. So I would say I greater than or equal to 0, and then don't forget to make this I minus minus. So now we're looping through the array backwards, right? And of course, we don't have to loop through the entire array. We could start at any specific index we want and loop to any specific one. We also don't have to use a for loop. Quite often, using a while loop is effective as well. So lots of different things that we can do there. The last thing I want to go over is how to swap two elements in an array. So we've already dealt with this when we did our picture lab. We know that swapping is something you have to be careful with. So let's take a look at what if I wanted to swap. So I'm going to say this is me swapping the value at index 2 and 5. So I could say array bracket 2 gets array bracket 5, and then array bracket 5 gets array bracket 2. Well, this does not work. That doesn't work. Let me show you why. So, let me just clear out all this for a second. So let's just say that our array starts right here on the first, so this is array. It's pointing right here. In other words, this would be array bracket 0. Okay, and it was 8, 6, 7, 5, 3, 0, 9. I hope you know that song. Anyway, that was my array, right? And I said I wanted to swap what was in index 2. So this is index 2, right? This is bracket 2 with 3, 4. This was bracket 5, right? So the first thing I did was I said array bracket 2 gets what's in array bracket 5. So this, what I can actually do is I can go over here and I can say, Control C, and then go over here and say Control V, and I'm just going to copy it right over. And then I said, okay, after that I said, well, then I need to set array bracket 5 to what's in array bracket 2. So I went over here and I grabbed this 0 and I just copied it right back. So the array bracket 2 is got what it should have, but this has got itself still. So what I need to do instead is make another variable, a temporary variable that allows me to do this. So I'm just going to say, the variable type is an int. So I'll say int val, equals array bracket 2. So now that I've done that, when I copy over array bracket 5 to array bracket 2, I've got this other value. So let me go back in time here. We're trying to swap these two values. So what I'm going to do is I'm going to make a copy. So I'm going to say my val, right? I'm going to say val, and I'm going to make a copy of this number right here. So it goes there. And then the next step is we're going to take what's in 5, and we're going to copy it over what's in 2. And then, lastly, I need to take what is in val and copy it over in 5. And now I've effectively swapped the two. So array bracket 5 doesn't get array bracket 2. That wouldn't work. It gets that val that I kept as a copy. So that's how we swapped. And I think there was one more thing I needed to do. I know I probably said that was the last thing, but I need to show you one other thing. The AP Computer Science curriculum requires that we know how to make an array like this, but we also need to know how to make it with an initializer list. So when you make an array with a list of things that you already have, you don't put the size in here. You leave it blank. Now remember, to make an array, Java has to know how many elements it'll be. So when I leave it blank, that's me signaling to Java, hey Java, I'm about to give you the initial values. And so I can say this, 8, 6, 7, 5, 3, 0, 9, in curly braces. And what that does is, instead of filling it in with all zeros that I then go back and fill them in one at a time, it will make the array, it will figure out the length based on how many numbers there are, and fill them with those values. So just another way to make an array, and that's called an initializer list. And of course, we can also have arrays be instance variables, which they often will be. So I could have said something like this, but I would need a constructor that would possibly take in an array and set it and then I wouldn't need to do that anymore because I already have the array. Or perhaps I use some logic in my constructor to fill this in. When testing a class such as this, you'll need to make an array yourself. You could say new, because it is an array. Because it is asking for an array, we can say new int curly brace, and we can just list it right there. And it works that way. And you can see that I have an array for a field. Notice that it has the variable length because there's 7 numbers, and then 0, 1, 2, 3, 4, 5, 6. Okay, so you've got a task ahead of you. I'd like you to complete this summing and inting array, summing and moving an array. So it'll be dealing with arrays of int values, which is what we've been talking about. So you'll get, I want you to write this class. So it uses a constructor to set this value, and I want you to complete these different tasks. So the first one is get sum. It will return the sum of 2 integers located at index 1 and index 2. The next method, and I'm using java.comments, right? This at param is a description of the parameters. At return is a description of what it returns. This one returns a sum of all of the numbers in the array from the index, this index, up to that many numbers. So, for example, if I called it with an index of 4 and nums was 5, it would sum at index 4, 5, 6, 7, 4, 5, 6, 7, 8. Yeah, just to 8. And then lastly, I have something called move zeros, and this will be more challenging for some of you. I want you to take the array, and I want you to keep all the numbers that were in there to stay in there, and I want the order of the elements to remain the same, except for I want all zeros to be moved to the end. So, for example, if I had this this array here, the only thing that would happen is that this 0 needs to move to the end. And then the 5 needs to come forward. The 3 needs to come forward. The 7 needs to come forward. The 9 needs to come forward. And the 0 needs to go there. So don't change the order of the other numbers, okay? Maintain the order of all the other values. Just have the zeros move to the end. So good luck, and let me know if you need any help.